Welcome to Part 18 of our AI Audit Exam Prep series. In this session, we are covering data management tailored for artificial intelligence. Understanding this is crucial because data is the lifeblood of any automated reasoning tool. Let us talk about real-world utility. As a professional or auditor, mastering this helps you look at a corporate initiative and immediately spot whether the underlying information is reliable enough to support a safe deployment. You will be able to evaluate if an organization is legally protected and technically prepared to launch a smart system rather than just hoping it works out. Traditional programming is like giving a chef a strict step-by-step recipe to bake a cake. You write the exact rules and the computer follows them precisely. Artificial intelligence operates entirely differently. Instead of giving the system a recipe, you give it 10,000 pictures of successful cakes and failed cakes, allowing the system to figure out the patterns on its own. In this world, the data itself becomes the programming code. Because the system learns solely from what it is fed, poor information hygiene leads directly to catastrophic system failures. When a system generates completely fictitious or nonsensical outputs, which experts call hallucinations, it is usually because the underlying training material was heavily biased, incomplete, badly labeled, or just plain irrelevant. Before a system can learn, an organization must gather the learning materials into a centralized location. Think of this like building a massive centralized library. Many organizations struggle initially to convert old paper records into digital formats, but once they do, they dump everything into massive storage repositories known as data lakes or data warehouses. There is a direct positive correlation here, meaning the larger the volume and the wider the variety of this collected information, the more accurate and highly performing the final algorithmic model will be. To evaluate these massive digital libraries, we use a framework known as the 5 V's. First is velocity. This measures how fast new information is being generated and moved through the network, similar to measuring the speed of a river current. Second is volume, which is simply the sheer physical size of the stockpiled information. Third is value, meaning the actual practical benefit a business can extract from holding this information. Fourth is variety. This refers to the diversity of the formats, such as mixing text documents with audio recordings, photographs, and video clips. Finally, we have veracity. Veracity is the ultimate measure of quality, looking at whether the information is completely accurate, highly credible, and free from tampering. Gathering all this information introduces significant hazards, starting with consent. Internal corporate documents are usually safe to use, but customer information is heavily restricted. Imagine you gave a mechanic your car keys strictly to change the oil, but they decided to use your car as a taxi on the weekends. That entirely violates the original agreement. Similarly, using personal details for algorithmic training requires explicit permission based on the exact terms agreed upon during the initial collection. Frameworks like the General Data Protection Regulation, or GDPR, make this mandatory. Furthermore, the European Union AI Act dictates that you must secure explicit, informed consent before anyone can be subjected to real-world testing of high-risk automated tools. Organizations must establish robust processes involving privacy and legal stakeholders to track who has opted in and who has opted out. If a user revokes their permission, the company must have a technical mechanism to physically remove their details from the training pipeline. Failing to do this can result in massive regulatory fines and a complete loss of customer trust. The next major hazard is ensuring the project is fit for purpose. This simply means the tool is genuinely capable of achieving the specific business goal it was designed for. You would not use a sports car to tow a heavy freight trailer because the vehicle is naturally not fit for that specific purpose. There are 3 major warning signs that a project is not fit for its intended use. The first warning sign is accessibility. The necessary metrics might exist somewhere inside the corporate network, but if the development team cannot easily reach them to train the model or feed the inference engine, the project will stall. The second warning sign relates to the quality of the details. The gathered material might lack the necessary granularity, depth, volume, or veracity required to teach a complex algorithm effectively. The third warning sign is regulatory. The entire intended use case might simply be restricted or prohibited by regional laws governing high-risk deployments. The final risk factor we must discuss is data lag. Teaching a complex algorithmic model is incredibly resource intensive. Depending on the computational hardware and the sheer volume of parameters, the learning phase can take weeks or even several months. This creates a dangerous blind spot. By the time the system is finally deployed, the historical data it memorized is already outdated. Over time, this gap between what the system learned and the current reality causes a severe drop in real-time accuracy, a phenomenon experts call model drift. Think of it like studying for an exam using a textbook printed 5 years ago. Your answers will be perfectly aligned with the old book, but completely wrong for today. Organizations can solve this lag in two distinct ways. The first method is to periodically pause and retrain a new version of the model using freshly updated datasets. This works best if the model is small and you are just updating simple feature weights. The second method is a clever technique called retrieval augmented generation, often abbreviated as RAG. Instead of forcing a massive language model to memorize new facts, RAG acts like an open book test. Before the base model answers a prompt, it quickly looks up specific, up-to-date facts from an external database and then uses that fresh context to formulate its final response. Let us review what we just covered. We explored how algorithmic systems rely entirely on the quality of their learning materials, contrasting this directly with traditional programming. We broke down the 5 V's of big data evaluation, which are velocity, volume, value, variety, and veracity. Finally, we analysed 3 critical operational hazards. These were the legal necessity of obtaining and managing consent, the importance of ensuring a project is functionally fit for its intended purpose, and the strategies for combating data lag using retraining or retrieval augmented generation. To fully cement these concepts, I highly recommend logging on to RooCloud.com. All the important topics and concepts from this session are covered in the multiple choice questions there. You should ideally solve the chapter-wise questions to reinforce your learning before moving on to the next session. Thank you for your focus today, and good luck with your continued studies.